Streamlining manufacturing processes. An in-depth analysis of SMED techniques. Introduction. Welcome to the presentation on streamlining manufacturing processes using SMED techniques. This in-depth analysis will explore the benefits and implementation of single-minute exchange of die (SMED) in optimizing manufacturing operations. What is SMED? SMED, or single-minute exchange of die, is a methodology aimed at reducing setup time in manufacturing processes. It focuses on quick changeovers between different production runs, minimizing downtime and increasing productivity. By identifying and eliminating non-value added activities, SMED enables companies to achieve greater efficiency and flexibility in their operations. Benefits of SMED. Implementing SMED techniques offers numerous benefits to manufacturers. These include reduced setup time, increased production capacity, improved product quality, enhanced workplace safety, and greater customer satisfaction. By streamlining manufacturing processes, companies can achieve cost savings, faster response times, and a competitive edge in the market. SMED methodology. The SMED methodology consists of three key stages: preparation, conversion, and improvement. During preparation, the team analyzes the current setup process and identifies opportunities for improvement. The conversion stage involves separating internal and external setup activities to reduce downtime. Finally, the improvement stage focuses on continuously refining the setup process for maximum efficiency. Internal versus external setup. Differentiating between internal and external setup activities is crucial in SMED. Internal setup refers to tasks that can only be performed when the machine is stopped, while external setup activities can be carried out while the machine is still running. By minimizing internal setup time and shifting tasks to the external setup, manufacturers can significantly reduce downtime and increase productivity. Study the all setup change procedure activities. List down all internal activity and external activities. Calculate total setup time. Then brainstorm all acidity with the cross-functional team and take action for setup time reduction, or if possible eliminate setup change activity by some automation or other action, or think about how any internal activity can be converted as external activity. After doing this, your internal activity time will be minimized. Then take an action of all external activities by reducing the time or by elimination of process. After this, you will find total setup time will become a single-digit number. SMED techniques. Quick die change. One of the core SMED techniques is quick die change, QDC. This involves optimizing the process of changing dies or tooling in manufacturing equipment. By implementing QDC, companies can reduce setup time, increase operational flexibility, and improve overall equipment effectiveness, OEE. QDC techniques include standardized tooling, die carts, and parallel operations to minimize downtime. SMED techniques. Standardization. Standardization plays a vital role in SMED implementation. By standardizing elements such as tooling, equipment, and procedures, manufacturers can simplify changeover processes and reduce setup time. This includes using modular tooling, color-coded components, and visual aids to ensure quick and error-free setup. Standardization promotes efficiency, reduces errors, and enables easier training of new operators. SMED techniques. Eliminating adjustments. Eliminating unnecessary adjustments is another key aspect of SMED. By designing equipment and processes that require minimal adjustments during changeovers, manufacturers can significantly reduce setup time. By designing equipment and processes that require minimal adjustments during changeovers, manufacturers can significantly reduce setup time. SMED techniques. Parallel operations. Parallel operations involve performing setup tasks simultaneously rather than sequentially. By identifying and executing tasks that can be done in parallel, manufacturers can reduce setup time and increase efficiency. This includes activities such as preparing tools, cleaning equipment, and verifying settings. Parallel operations maximize machine uptime and minimize production interruptions during changeovers. Real-world examples. Numerous companies have successfully implemented SMED techniques to streamline their manufacturing processes. Examples include Toyota, which revolutionized automotive production with its Toyota Production System, and General Electric, which improved turbine manufacturing efficiency through SMED implementation. These real-world examples demonstrate the tangible benefits and competitive advantage that can be achieved through SMED. Challenges. Considerations. While SMED offers significant advantages, its implementation can present challenges. These include resistance to change, lack of employee engagement, and complex process analysis. It is crucial for organizations to address these challenges through effective change management, employee involvement, and thorough process evaluation. Overcoming these obstacles ensures successful SMED implementation and long-term process optimization. Measuring success. Key metrics. To gauge the effectiveness of SMED implementation, companies utilize key metrics such as setup time reduction, increase in production capacity, downtime reduction, defect rate improvement, and customer feedback. These metrics provide valuable insights into the impact of SMED on manufacturing processes and overall business performance. Regular monitoring and analysis of these metrics ensure continuous improvement and sustained success. Best practices for SMED implementation. Successful SMED implementation requires adherence to best practices. These include cross-functional collaboration, employee training, continuous improvement, and knowledge sharing. By involving all relevant departments, providing comprehensive training, fostering a culture of continuous improvement, and sharing knowledge across the organization, companies can achieve optimal results and maximize the benefits of SMED. Case study. Company X. In this case study, we explore how Company X, a leading manufacturer, implemented SMED techniques to streamline their production processes. We will examine the challenges faced, the solutions implemented, and the measurable benefits achieved. This real-world example will provide valuable insights into the practical application of SMED and its impact on operational efficiency. Key takeaways. As we conclude this presentation, let's recap the key takeaways of streamlining manufacturing processes using SMED techniques. SMED enables reduced setup time, increased production efficiency, improved product quality, enhanced workplace safety, and greater customer satisfaction. By implementing SMED techniques, companies can achieve cost savings, faster response times, and a competitive edge in the market. Conclusion. In conclusion, streamlining manufacturing processes using SMED techniques is a powerful approach to optimize production operations. By implementing SMED, companies can achieve efficiency, flexibility, and competitive advantage. Through techniques such as quick die change, standardization, elimination of adjustments, and parallel operations, manufacturers